Hello and welcome back to Get Great at Maths. I'm here to help you pass your maths exam, so hit that like and subscribe button. We're going to look at keywords, key formulas and how to gain top marks. So let's get ready to get great at maths. We're looking at doing an integration question using partial fractions. Now integration is tricky because it's difficult to know which type of integration you're going to use, and this question is not obvious that you've got to use partial fractions for it. But if your denominator will factorise into two or more brackets, then you're going to be using partial fractions. In this case, the denominator is the difference of two squares, which is x plus 1, x minus 1, so the denominator will factorise into two brackets, which means we can split it up to be a over x plus 1 plus b over x minus 1 for two fractions. Now we're going to put the right hand side over a common denominator, so I need to work out what am I going to multiply by a by to end up with a over x plus 1 when I multiply x plus 1 and x minus 1 together. So the answer is a times x minus 1, because if those x minus 1s will cancel, leaving you back with a over x plus 1. A similar thing can be done for the b. So b times by x plus 1 all over x plus 1, x minus 1 would cancel down to b over x minus 1. We can then compare the numerators. So 2 is identically equal to a x minus 1 plus b x plus 1. From here we need to find the values of a and b. So to do that we're going to let x equal different values. And the first value I'm going to use is x is 1. So that first bracket disappears because 1 take away 1 gives me 0 on the right hand side. If I put 1 in front of the b, I get 1 plus 1, which is 2. So I've got 2b on the right hand side is equal to 2. Therefore b is equal to 1. The next value I'm going to use for x will make the second bracket disappear. So to get rid of the plus 1 in the bracket, I've got to use x equals minus 1. So I've got 2 is going to equal a times by minus 1, which will be minus 2a, plus b times by minus 1 plus 1, which is 0. So I've got 2 is equal to 2a. I can divide both sides by minus 2. So a is equal to negative 1. I can then put these back into the separate fractions. So the question is going to equal minus 1 over x plus 1 plus 1 over x minus 1 with respect to x. Remember to put your notation in on these questions using your integral sign and your dx. Now we need to think about which key formula we're going to use to be able to integrate this. So the key rule that you're going to use is that the integral of 1 over f of x dx is equal to 1 over the differential of f of x, so f dash of x, times by ln of f of x plus c. So the integral of minus 1 over x plus 1 is minus ln of x plus 1 divided by the differential of x plus 1, which is 1, which will just keep it the same. The second term, we've just got ln of x plus x minus 1. The differential of x minus 1 again is 1, so when we divide by 1 it doesn't affect the answer. We've now got two terms in terms of logs. Now if in the exam they didn't ask you how to leave your answer, the answer you've got is absolutely fine. But we can combine these two logs using the rule that's just appeared on the right of log a minus log b is log of a divided by b. So here I can think of it as log of x minus 1 minus log of x plus 1. So I've got ln of x minus 1 over x plus 1 plus my c. Now in this question I've got a fraction where I've got a repeated root in the denominator. So I've got x minus 2 all squared. This means I'm going to have to split my fraction up into three sections using partial fractions. So I get a over the 2x plus 1, b over the x minus 2 all squared, plus a c over an x minus 2. Now we've got to work carefully to get the denominators the same on both sides and work out what the numerator is now going to be. So the denominator is going to be 2x plus 1 times by x minus 2 all squared. Now to get that denominator for the a term, you just need to multiply the a term by an extra x minus 2 all squared. The b term needs to multiply by an extra 2x plus 1. But the c term, to end up with the denominator of 2x plus 1 x minus 2 all squared, all you need to multiply by is a 2x plus 1 and one of the x minus 2's. So then they would cancel down to leave you with c over x minus 2. Now we need to work out the values of a, b and c. So if I let x equal 2, I can substitute 2 into the left-hand side, substitute 2 into the right-hand side, and then we can solve to work out the value of b. So 8 times 4 minus 19 times 2 plus 1 is going to equal 0 plus b times by 4 plus 1 plus 0. And you can rearrange that to find that b is equal to negative 1. Then I'm going to let x equal negative a half because this will get rid of the bracket on the end. So this will get rid of the c bracket and it will also get rid of the b bracket. So we're left with 8 times half squared, which is a quarter, minus 9 times minus a half plus 1 is going to equal a times by minus a half minus 2 all squared. So a will equal 2 if you solve that. Now, because we've got a third term and we've only got 2 different brackets, we have to compare coefficients. So I'm going to compare coefficients of the x squareds. It could be compare coefficients of x or the constant. It doesn't matter. You will end up with the same answer. And you can check by comparing the coefficient of a constant or a different one to check that you haven't made any mistakes. So if I'm comparing the x squared, on the left-hand side, I've got an 8. On the a term, the first term, I've got an a times by the x squared, so I've just got an a. The middle term with the b in, there is no x squared term. On the last term with the c, I've got c times by a 2x times by an x, which gives you 2c x squared, which means the coefficient is 2c. Now we know the value of a is already 2, so I can substitute that value in. Then I could subtract 2 from both sides to give me 6. So 2c is equal to 6, therefore c is equal to 3. I can then substitute all these 3 terms back into the integral. Now I've got to integrate each of these 3 terms, and the rules we're going to be using are the key formulas. We're going to be doing the integral of 1 over f of x dx is equal to 1 over f dashed of x ln of f of x plus c. And the next rule we're going to be using is the integral of f of x to the power of n dx is equal to 1 over n plus 1 times by the differential of f of x and then the bracket to the power of 1. So n plus 1, then add on your c. So basically you take your bracket, add 1 to the power, divide by the new power, and then divide by the differential of what is in the bracket. So this rule will be used for the middle term, so for minus 1 over x minus 2 all squared. You need to write as minus x minus 2 to the power of minus 2. The outside 2 terms, you're going to use the top rule or the top formula. So we're going to use the ln. So in the first one, we have got 2 over 2x plus 1. Now if I integrate this, I've got 2 over ln of 2x plus 1. Now the differential of 2x plus 1 is 2, so I've got to divide by 2, so both of those 2's will cancel. The middle term, I've got x minus 2 to the power of minus 2. Add 1 to the power gives me minus 1. Divide by the new power gives me minus 1. The 2 minuses then become a plus. And then the differential of x minus 2 is just 1, so we're just divided by 1, leaving me with x minus 2 to the power of minus 1, which is 1 over x minus 2. The last term, I've got 3 lots of ln of x minus 2. The differential of x minus 2 is 1, so we're just divided by 1, so it doesn't change the answer. From here, I can use rules of logs. So I'm going to use ln of a plus ln of b is equal to ln of a plus b. But before I can use that rule, I have to use the power rule and I have to bring the 3 up to the power. So I get ln of x minus 2 all cubed. Then I can combine them together using the ln rule. So I get ln of 2x plus 1 times by x minus 2 all cubed plus 1 over x minus 2 plus c. Now this example is different. The numerator is a higher power than the denominator. So all the other ones, the numerator and the denominator have been lower powers or the same powers. But in this case, the numerator is a higher power than the denominator. So to deal with this, we're going to use long division first. So I'm going to divide x squared by my x plus 1. So I say how many times does x go into x squared, which is just x. So that goes written at the top. Then I do this green x times by the pink x, so x times x gives me x squared. And then I do the green x times the pink 1, which gives me x. I then subtract these 2 values, so I get x squared, take away x is 0. 0x take away 1x is just take away x, and the plus 0 just carries on the right hand side. And now say how many times does plus x go into minus x? So x into minus x goes minus 1. So minus 1 times x gives me minus x. Minus 1 times the pink green one gives me minus 1. I can subtract these and gives me 1. So to write this expression in partial fractions now, the bit at the front, x minus 1, is called your quotient, and the 1 at the bottom in yellow is called your remainder. So the integral of x squared over x plus 1 dx is the same as x minus 1, so there's my quotient, the whole part that we've got, plus my remainder, which is 1, over the original fraction that you're dividing by, which is in pink, x plus 1. And that is integrated with respect to x. Now to integrate this, we're going to use the key fact that 1 over f of x dx is 1 over f dash of x ln of f of x plus c again. So that's to integrate the right part of this fraction. The first two parts are just normal integration. So integrating x, you get x squared over 2. The integral of minus 1 is just minus x. Then I've got ln of x plus 1 divided by the differential of x plus 1, which is 1. So it doesn't change the answer, giving me plus c. If you've enjoyed this video, please don't forget to like and subscribe. Comment below to let me know what you would like to see in my next video. See you next time!